Welcome to Walk About the Galaxy, the feel-good astronomy podcast where the science is universal, the opinions are personal, and the self-promotion is shameless. We are Strange Charm atop the astroquarks, also known as Josh Caldwell,
Addie Dove,
and Jim Cooney,
coming to you from an undisclosed location near the University of Central Florida. Remember to check out our website to see how to get our snazzy shirts and subscribe to us on all platforms, including YouTube, where you can catch our first and soon-to-be Grammy-winning music video, the Astroquarks song. Our stumpers today are science fiction-y. Game?
Game.
Okay.
Set.
Match. Jim.
Yeah.
You were a tennis coach, is that right? Speaking of game, set, match.
Yeah.
Yeah, but do you still play?
Not as often as I should.
I was just
Not
reading,
since the beginning of COVID.
So I was just reading about activities that are good during COVID, though, and
tennis
actually
is one
tennis
of
is one of them.
Yeah,
so
yeah.
let's go play sometime.
Yes.
I'm
Because you're
awful, probably. I
Well
play twice.
separated.
You're well
There's just
separated,
two of
right.
you.
Exactly.
Yeah.
Just as long as you don't like sneeze on the ball and then
Right.
hit it to the next person's face.
Yeah, no. Of the things you can do, it's one of the better ones, yep.
Okay. Running around an empty neighborhood by yourself is also
Also
pretty
pretty
safe.
good. Yep.
The problem is that it's been 99 degrees all the time here.
Yeah.
Yeah,
With
you're going to
98%
die, just not of
humidity.
COVID.
Right, yeah.
Heat exhaustion.
Okay, Jim. Tractor beams
Yeah.
or force fields?
Yeah.
I almost made a farming joke.
Are they even different things?
I don't even know.
Or is it
there's
the same thing on a different setting?
They're just like, I want to pick the one that is most theoretically possible, or I don't know.
Which one's
Tractor
that?
beams have always struck me as ludicrous, and so I'll go with the other one, force field. Because tractor beam, like, what is a tractor? It's like it's just like
tractor beam
It's a beam
is-
they shoot at you, and all of a sudden you're sucked into that thing.
It locks onto
Locks
you, Jim.
onto you, and,
Yeah.
then it drags you in.
Like a tow hook.
Well, then you can
Like-
pull it in.
What is the force?
The
Which of nature's four forces are they using?
It's kind of like the Star Wars Force.
It's
In the way it works, it's kind of like the Star Wars
Yeah.
Force.
Which is
But it's-
very non-scientific. Force fields, I can imagine like
Some
some
sort
kind
of
of thing,
like-
like a powerful electromagnetic field
Yeah.
that deflected some kinds of things, like a bullet or something that's metal or something like that. And I guess a tractor beam, if it was just pulling metal things in, but that doesn't seem to be how they work.
Also,
Well, you
force
have to
fields
like
is usually
beam something out there,
Yeah.
and that's just going to keep going.
Yeah,
It's not going to like stop on a thing.
No.
And a force field too is often like somebody will touch it and be like, "Ah, that hurts," and then it could just be like a electric
a sparky.
field kind of
It
thing.
could be.
Well, there are force fields for like dog collars.
Yeah,
yeah.
Where they
exactly.
put-
Force field is general enough that that's a realistic thing that could be, not
Yeah.
obviously all the manifestations in every sci-fi thing, but tractor beams seem ludicrous.
It would
so
be
boo
cool
on
if,
tractor beams.
if in Star Trek, if the force fields were like those dog e-fences or whatever,
Yeah.
where you just
are so
like
mean.
you just get shocked.
Yeah.
You're just like, oh.
I do
That's kind of
sometimes.
what it seems like, though. Like they touch it and it hurts, right?
Yeah.
So,
Well,
Just,
but they
for
can't.
some of the force fields. in
Sometimes they really
sci-fi.
try to go through it and they can't.
That's true.
I mean, they do use tractor beams well. I think in some of these, like when they in Star Wars when they get the thing, like it builds good.
That's true.
tension and that kind of
the
stuff.
tractor beam is one of the things that Star Wars copied from Star Trek, or
Right.
maybe it's a generic enough thing that they both copied it from something else.
That's
But
possible, yeah. But they used it well, and it's good. It's just it's scientifically so ludicrous that I say
Yeah.
boo.
I mean, it's just the future version of a toe.
it'd be interesting. Yeah, it'd be interesting to go through the list of sort of like sci-fi gimmicks that
The evolution
that
of
are-
the tractor beam.
that are in both Star Trek and Star Wars, because there are some that
okay.
are in both, but there's some like the transporter is purely a Star Trek thing, right? But
Soon to be real life.
ray guns and like being able to walk around on a spaceship like there's gravity, that's universal.
Pretty generic sci-fi.
Yeah. Okay.
Space sci-fi.
What did you say? Force fields.
Force fields.
Addie,
Hello.
Vulcan mind meld or Jedi mind trick?
Vulcan mind meld?
Once when I was a little kid, we were playing Star Trek with
Are
my
you so glad I answered that
with
one?
a friend, and I was of course being Spock,
Of course.
and I was of course doing a Vulcan mind meld on my friend.
Uh-huh.
And I haven't seen this kid in 45 years or something, But I still remember this very well because
He's probably not a kid anymore.
probably not. But in my mind, he'll always be the recipient of a Vulcan mind meld and the son of a mother who laughed in a very ridiculing fashion at our Vulcan mind meld, which I am now forever scarred.
Oh,
Did it work?
it seems.
The Vulcan mind meld?
Yeah. Could you read his mind or her
Oh,
mind?
yeah. Oh, yeah.
yeah.
Yeah. Okay.
Yeah.
It seems like it's an interesting conceit.
The mind meld?
The mind meld. And in some way, there's a lot of and speaking of there's versions of that kind of thing in a lot of different lore, I would say, of ways to
telepathic
be in mind
stuff.
sync, telepathic stuff, yeah.
But neither one of them do I like because they take the science fiction and make it fantasy.
Fiction?
No, they just make it less hard science
less
fiction
science-y.
and more fantasy-ish.
Wow.
Yeah.
Yeah. But it is
And they
what
do
it is.
some cool things with the Vulcan mind meld throughout Star Trek.
Yeah.
Like there's some important stuff that happens via that.
Yeah, and it also opens up a lot of good sort of dramatic effects because of the fact that it's very emotional, but it's only done by these by these people who are always trying to keep their emotions in check.
Yeah.
I feel like there's an interesting use of it in Enterprise, but I don't know.
Well, today we'll be talking about lightning on Jupiter, the important role of the oft overlooked low-mass stars. There's a new Star Trek show called Lower Decks, so this is sort of like the lower decks of stars.
It's not, though.
More Starlink satellites are up in space. Asteroid pieces are heading back to Earth in tiny spaceships. But first, this episode of Walkabout the Galaxy is brought to you by Celestial Mechanics. You can take your problems with levers and pulleys downtown to the folks at Classical Mechanics and your misbehaving, unpredictable subatomic particles to the difficult to pin down about anything team at Quantum Mechanics. But if you're having problems just getting around the solar system, the Milky Way, or even the local group, come see us at Celestial Mechanics. Our trained professionals will integrate your orbits to whatever degree of precision you require. Get our gold service if you need to account for general relativity, or for a short jaunt around the planetary neighborhood, bring your trajectory in for our standard and comprehensive 49-point checkout, where each vector is verified to double precision with a money-back guarantee. Celestial Mechanics. Zoom, zoom.
Zoom, zoom. Mazda.
Yeah.
Nice.
Yeah.
You knew that too, didn't you?
I did not.
You didn't?
I
Nope.
love that one.
I thought it was
Zoom,
a car company, but I couldn't have guessed it.
zoom. Couldn't place it.
Didn't know it. Never owned a
I have
Mazda.
a lot of random car knowledge. Also, I like the word zoom. Zoom, zoom.
That commercial
Less these
always
days.
freaked me out, though. There's
Which
this.
one?
Well, the Zoom Zoom commercial I think of is this little kid who's like dressed in a suit, like he's wearing a black suit and tie, and he's standing by himself on the side of the road in the countryside, and he's always like turning to the camera and going, "Zoom, zoom," and it's always made me think
Was
of
this
like,
just a nightmare you had?
this is the commercial. You don't remember this commercial?
They've used it in a couple commercials, but yeah.
I was like, what is this?
I didn't
The
remember it
spawn of
being that
Satan or
creepy.
something? I mean, he seemed like a very creepy little kid. Like, what is this kid doing dressed up in a suit in the middle of nowhere, whispering zoom, zoom? It's like, he's going to come and get me.
Did you know that commercial was made? Oh no, I just blanked on the name of the person I was going to say. It was going to be a great joke, though.
I would have laughed a lot at
I
it,
know.
I'm sure.
You would have been like, really?
Damn.
And it wouldn't have. M. Night Shyamalan, that's what I was going to say.
M. Night Shyamalan?
Yeah. That's why there's a twist. That's why there's a twist at the end. Anyway.
Do you know that the Hayabusa 2 asteroid sample is on its way back?
I did know that.
It's landing on December 6th, 2020.
Indeed, in Australia.
Yes.
Hayabusa 2 is the Japanese mission to an asteroid
Ryugu.
named Ryugu. And it already contacted the asteroid a couple times, and now it's coming back. It's on its way back.
It's definitely going to have some stuff.
Do
in
we
there.
have a
I
good
don't-
idea? Yeah, I was going to say of how much, because remember the Hayabusa 1 was
It came back with,
largely a
like-
failure, right? It came back with only a few bits of dust from the surface.
We
when it was
learned a
trying-
lot from the mission, but it didn't return
Right,
a
right.
lot.
So it did some things, but it didn't do the kind of main thing that it was trying to do. But this one, do we know? Does it have a big?
We won't know until they open it up how
I
much.
think they have an estimate of how much. I think they like have some sensors right inside the containers and like
Oh,
the
the-
spacecraft mass and stuff like that. So they have an estimate of how much.
Yeah.
And
Do you know what
But
that
you're-
estimate is? No?
It's some.
Some.
Like
Some.
they got on the higher end of what they were hoping. I think.
Oh, good.
Definitely, Hayabusa 1, as you said, just got a few like dust grains, so
Right.
like micrograms of that asteroid, which is disappointing on the one hand, but it's still freaking amazing that they managed to send a spacecraft to an
Yeah.
asteroid
And bring it back.
get a single thing and
Yeah.
then bring it back and land it in Australia.
Yeah.
Yeah.
You
I
think
remember
about all the
having a
things that
huge
can go
argument
wrong.
with somebody about whether, I mean, maybe it wasn't me, but about whether this was a success or a failure, whether the Hayabusa 1 was a success or failure. But
You might have been having that argument with yourself.
Possibly.
You're mentioning, yeah,
yeah, I often do.
yeah.
I don't know who won.
This one, just from the videos that we've seen of their sampling, everything seemed to go kind of as you would expect. Lots of big pieces of stuff were flying around. So
Awesome.
I would guess that it won't be micrograms or milligrams, but at least grams of
Excellent.
material. Yeah. That's landing in Australia, as you said, December 6th.
Yeah, it's a capsule that comes in. It's got some parachutes and it lands in the desert in Australia.
They have a cooperative agreement with the Australian
Yeah.
Space Agency, and there's all sorts of like funny people are funny. We do strange things, and so like they have to have all these sort of agreements in place to like transfer of interplanetary material from one country to another country.
Yeah.
To like
Send it FedEx.
have that agreement in place.
DHL, right?
Yeah.
But seriously, they actually have like they're not just like, okay, you go pick it up and we'll send it over to you. No, we have to have all this formal stuff worked out.
Right.
Did either of you get up at 1 a.m. to see the most recent
I was
batch of
awake
Starlink
in
satellites?
bed on Twitter, but I didn't get out of my bed to go see the more.
I didn't either, but that was the 10th,
Yeah.
I believe, Starlink launch. And there have
Crazy.
been, because they normally do 60 satellites per launch, but a couple times they've taken some piggybackers.
Yeah.
So they've launched 597
So somewhere
Starlink
around
satellites
500.
so far. They've already deorbited 5 of them.
I was actually just looking on Space Track earlier today, which is the website that like tracks all the satellites in orbit. So I was looking anyway. CubeSat you can track on there and all that stuff. So I was randomly on there earlier today, and there's like 5, and there's like 5 more Starlinks that are going to deorbit in the next month or something like that.
Oh, really?
I think so. Yeah.
Because
Why?
they've got problems or something?
I think like a bunch of them were in really low orbits to start, and some of them from the earlier stuff didn't like get as high or something. I think I don't know.
Do these things have propulsion?
I don't think
They
so.
do. They do.
Oh, they do?
Yeah.
Oh yeah, they must have something.
They have propulsion.
Yeah.
They go into a low orbit initially, and they check them out
Yeah.
to make sure they're okay. Because if they're not okay and they can't boost them, the low orbit will decay naturally.
Right.
But if they're okay, then they boost them, and then when they're not good, they can use that thruster to deorbit them.
Right.
So,
But they,
Yeah, they're big.
These supposedly had some star shades.
and they've been improving their sort of anti-reflection
I feel like
tactics and
astronomers will
stuff.
still not be impressed.
Yeah. Anyway, that's a whole bunch of satellites.
It's so many.
And they're, going to be, I think I think they have 2 more launches of 60 scheduled for this month, August
What?
2020.
Crazy.
So there could easily be over 1,000 of these by the end of the year 2020, which would make it something like a quarter of all
Yeah.
satellites in orbit around the Earth. So,
Insane.
yeah.
Insane. They didn't catch the fairings this time.
They did not catch their fairing, but their first stage landed.
Yeah.
We've got a planetary update from Juno.
You do?
This is the mission whose sort of primary science goal is to study the deep interior of Jupiter by flying. Jupiter's problematic.
You know what they always say about Jupiter? It's really problematic.
It's problematic
Mostly people say it's big.
because it's your favorite stuff that
The moon?
makes it problematic. No,
The plasma.
Yeah.
Yeah, but that's also what Juno's studying mostly, right? Is magnetic fields, electric fields,
And the internal structure.
and the internal structure, the gravity fields.
yeah.
all the fields.
All the fields.
The force
It's
fields.
getting all the fields. Isn't that a thing people say? Young people say they go to
Yeah,
a movie and they
they
say,
have
"Oh, I
all the
got all the
fields."
fields."
It's definitely a thing
Yeah.
young people say.
Well, we're getting
this
all the
podcast gives me all the fields.
we're getting all the fields from this podcast. That's the title of the episode. All the fields. So the reason Jupiter is problematic is because of its magnetic field and Io, which is got all these volcanoes, and those are spewing atoms, mostly atoms, but some molecules, into the space around Jupiter.
And they
Those
get
things
caught
get
up.
charged
Yep.
by sunlight, and then now there you got charged particles in a giant magnetosphere.
Having a flashback to grad school and having to calculate the Ioplasma torus
Oh, I didn't have to do that.
in IP.
And so that it makes it an unpleasant radiation environment for spacecraft
Yeah, high energy radiation.
because they're zipping through and there's all these high energy charged particles,
Yeah, it's
high
complicated.
energy electrons and ions, and so the way they and to make the measurements that Juno wants to make, it's all about getting very close to the planet to sense all of the sort of bumps and wiggles in the magnetic and gravitational fields, which from a great distance, it just looks like a dipole if it's for the magnetic field and a sphere for the gravitational field. But getting close in those fields, if you can, put on your psychedelic hat, get all sorts of bumps and wiggles. So they need to get in super close. They have these big looping orbits where they come diving in very close to the planet, get their good measurements, but don't get too much radiation, then go zipping out to a safe place and catch their breath.
Yeah, and there's an interesting. So originally, Juno was supposed to go into a smaller orbit, which would have brought it closer more often. But it meant the mission probably wouldn't have lasted as long because of all this high energy radiation. It would have been bad for the spacecraft. But because of some
They had
fuel
some
issues and
yeah,
some thruster issues, everybody
some
has
spacecraft
those.
problems.
They sort of got stuck in their larger orbit, but they've actually been able to extend the mission that way, and so they're getting a lot of. They still get some really close passes, but they spend more time further out. So
Right.
the mission will be able to last longer that way, though.
Right.
But so that's been
And it
pretty
was
cool.
sort of an afterthought or a bonus that they put a camera of any sort
Yes.
on Juno because all the measurements that it was making are gravitational and magnetic and electromagnetic, and you don't need a camera for that. But how can you send a spaceship to orbit Jupiter without a
camera.
freaking
Go
camera?
off without a camera.
Especially
Crazy.
cameras. I mean, we're doing some. Addie and I are doing some of our space flight experiments where we're using cameras that are taking totally reasonable pictures, and they're like $20 cameras.
Yeah. Hundreds.
So,
Yeah. Just
so you
stick an
can-
iPhone on Juno. It'll be fine.
Just put a
Yeah.
Pi cam on there.
Yeah, there you go.
But so they did
No,
put it.
Pi cams are far too radiation sensitive.
Yes, I know. So they may have to spend more. I'm sure they spent more than $20, but they did
Probably.
put a camera on. And one of the things that's cool about Jupiter, it's got this very dynamic atmosphere. So they saw lightning, which we've seen before on Jupiter. But this lightning is something called shallow lightning.
Yeah, which actually means it's higher up. So it's like shallow in the clouds.
You're not going deep into the atmosphere. You're
Yeah.
going only a little bit from the top down.
Because our previous observations of lightning, we thought that it was further down in, so sort of where you would have the right temperature for like water to be at its triple point, basically, where you'd have like solid, liquid, gas, water, and they thought sort of that's the cloud region. That's like how we get clouds here on Earth, or lightning here on Earth is in those sort of clouds. So they were thinking that it was probably in those regions. But yeah, this new observations using some of the cameras on Juno indicate that it's probably higher up, and it has to do with ammonia vapor.
Which has a lower triple or a higher triple
Higher.
point. It's
Lower.
triple point
Yeah.
Right. The farther out you get in Jupiter's atmosphere, the colder
it is.
until a certain point, and
Yeah.
it starts getting
Well,
warmer
that's
again.
true.
But right, yeah. So this is in this troposphere still.
Right.
So the temperature is dropping as you go up, and ammonia is more volatile than water. So shallow lightning So these are sort of like
Ammonia is sort of like antifreeze, right? So it's like
Right.
So it's you can think of that as like you can have liquid at these colder temperatures.
right.
Right.
So it's making. Are there snowflakes of ammonia of
There's
antifreeze in
little,
these
like-
clouds
yeah,
that are
like hail mush. They're called some of them mush,
Mush
balls.
balls, yeah.
Like soft hail.
ammonia-rich hailstones. So they're not as hard as water ice hailstones would be.
Yeah, I think it still condenses on water ice crystals though, which is interesting. Like they have these ice crystals there that the ammonia condenses on, and then you get more ice crystals forming on top of it, and it's a sort of complicated thing. In our clouds, ice like crystals form onto little dust grains, right?
Right.
So you have to have something to nucleate.
So
bigger thing
the
to form.
solid water is the dust that the ammonia
Potentially,
collects
yeah.
on, and the
Right.
Yeah.
Right.
fun. I thought this is very cool because, I mean, we've known that Jupiter has these, beautiful cloud layers, right? White ones and yellowish ones and orangish ones for a very long time. So ever
Yeah.
since the kind of first telescopes, we've seen these stripes. But we still don't even really understand those patterns really well. I mean, we understand a lot of the physics why it's all these horizontal bands, and we understand that they're different clouds made of different materials, but exactly why they're forming at what points in the atmosphere and how high and low they are it's still not well known. And so this mission is teaching us a lot about that, which is cool.
And one of the side effects of this discovery is that there was a question about where is all the ammonia in those upper clouds.
Missing ammonia.
There's
There's missing water. There's missing
It's like
ammonia. We don't know where
it's
anything is in Jupiter.
It's like a
I
Nancy
think.
Drew series or something.
Oh man.
So one way to make the stuff disappear from up high is you turn it into mush balls or hailstones or raindrops or snowflakes, and then they're heavy, they're no longer buoyant, and they precipitate down to lower altitudes, and so you don't sense them at the higher altitudes and like you were expecting to.
Yeah. I will say also, one of the articles, and we'll post a link to one of the NASA articles, has this artist's, it's an illustration of the data, and it's sort of like a 3D illustration of these cloud tops and the lightning and the storms in
Very
Jupiter's
exciting
atmosphere.
looking.
It's frightening. It's like a monster rising up out of this goo mush stuff. It terrifies me.
Yeah. I
love it.
Every time I see these pictures, it makes me think of Carl Sagan's imagined ecosystem of cloud floating creatures in the Jupiter and Saturn and such.
Sadly, no evidence of that yet.
It looks like a tar monster from something. I don't
Yeah.
know what from though.
It's hard to imagine how you get life going without like liquid confined in a small space.
Right.
And it's hard to do that on a gas giant because we talk about these hailstones or mush
don't-
balls
yeah.
precipitating. It's not like they go splashing down onto a surface. They go down to where the temperature is warmer and then they just evaporate and rise back up again.
Right.
Yeah, you get these. Yeah, it's pretty cool. Pretty
Hard to
interesting
imagine,
structures.
but not necessarily impossible, right? I mean, our imaginations are...
We thought of tractor beams and force fields
That's true.
and Jedi mind tricks, so we've got some crazy
That's
imagination.
true. We think of awesome things, but we don't necessarily think of the actual things.
That's true. Yeah, where sometimes our imagination is tinged by a little too much optimism.
Yeah, or just like whatever is like it always amazes me looking back at like the science fiction of like the early 20th century or something like that, and they imagine all these amazing things, flying cars and all the other stuff, but what they don't have any idea about is
The
what
cell
really
phone.
happened, which is like data, right? I mean,
Right.
Yeah.
we don't have flying cars yet. We still don't have flying cars,
And
but
I'm
we do-
really pissed off about that.
yeah.
But if you look at like the Star Treks, right, and Enterprise even, which is the more recent one, they have like tablets and things like that. That each tablet has like one thing on it, and
Right.
they hand those out. Like it's electronic books. It's like a Kindle, but you can only have one book on each
Right,
thing.
right.
And they have like a bunch of those that they
Yeah.
have to do.
Yeah.
So we way overestimated what we'll do in some respects and grossly underestimated what we'll do
Right.
in other respects. So
Yeah.
who knows what's
Right.
really going on out there?
Okay, well, before we move out beyond the solar system, let me drop some trivia on you, which will transition us
We need a-
into our next topic of stars.
Dropping sound effect.
Is that what trivia dropping sounds like?
I don't know.
Oh, let me hear
I'll
it
think
again.
of it.
Okay.
I don't like it. I'll
It's-
think of another one.
Okay.
Okay.
So we're about to talk about low mass stars, and those are the most abundant stars. But because they're low mass, they're also dim.
Yeah.
So we don't necessarily see them very easily, even if they are nearby. So your trivia is simply to tell us how many star systems, A, and individual stars, 3, B, 2, Roman numeral 2.
What?
Never
It's not
mind.
important.
I gotcha.
How many star systems and how many stars are there
And all the star systems
within
and all the stars.
5 parsecs of Earth? And that's 16.3 light years for those who lost their parsec calculator.
I left
Okay.
it at home today.
How many stars?
How many star systems?
How many star
Some
systems?
of which
And how many stars?
may have more than one star
right.
in them.
Right.
They are
So-
called star systems after all.
Yeah.
Yes. So how many star systems, how many individual stars? For bonus, parts C would be how many of them are red dwarfs.
Oh.
Part D would be how many brown dwarfs.
Uh-huh.
And
Well, that's what I
part
was going to ask is where are we drawing the
Low
line?
mass line. Where's the low mass line
these are
drawn?
all stars of any type.
Yeah,
Most of them are
but
going
how-
to be low mass.
This is but this gets into this fuzzy, gross territory we may have talked about before. That like what defines a star, and brown dwarfs. Some people call them stars, some people do not.
Nobody calls them stars.
Okay.
Nobody calls brown dwarf stars?
Even though some brown dwarfs do
What do you call them?
fuse deuterium in their
Just
cores.
brown dwarfs? They're their own thing?
Brown
I
dwarfs,
think I agree.
yeah.
They are
They're
their own thing. I agree, but you could easily.
They're substellar.
You have to take Theodora's class this semester and find out.
All right.
All right.
Okay.
How many stars are there within 16 light years of the Earth?
Okay.
Got it?
Yes.
Got it.
Okay. And there will be
Done.
some additional bonus trivias on that.
Calculated.
So, as I mentioned Carl Sagan and his cloud monsters,
As one does.
and one of Carl Sagan had many famous phrases, one of which was that, do you know where I'm going?
Life finds a way.
No.
Oh, wait.
Dress.
All the feels? No.
No.
We are star stuff.
We are. Oh, yeah,
Yeah.
I should have guessed that one.
Yeah, you should have.
Sorry.
And a lot of the star stuff that we are is carbon.
Yeah.
Yep.
Yeah.
And so, except for hydrogen in the water that was from the Big Bang, pretty much everything else in our bodies comes from stars, and a lot of what's in our bodies in life is carbon.
Right.
And the way star stuff gets into your burrito or,
Oh, my.
chocolate chip cookie or Coca-Cola is
All delicious.
I haven't had dinner.
Good
so
choices.
is from the star has to get rid of it somehow.
Right.
First has to make it,
Yeah.
Yep.
then it has to get rid of it.
Yeah.
Yep.
Yeah, and this is actually very interesting because, like, when I've often taught stuff about stars in an intro astronomy class, I really sweep under the rug this issue of like, where does the carbon in our bodies come from? We say it's recycled from stars, but then we go on to tell the story of like a low mass star, and the story of a low mass star is it makes this, it fuses hydrogen into helium in its core until it runs out of hydrogen in its core, and then it fuses helium into carbon in its core until
Then
it
it goes
runs
through
out
the
of helium.
CNO
And now
cycle.
it's a big
Just
ball
kidding.
of carbon, and outside of that is this big giant sheath of basically mostly hydrogen and
Right.
helium. And it blows that gently off in a thing that's called a planetary nebula, right? And then what's left behind
It's
is the
also
white
called,
dwarf.
blowing gently off is also called letting someone down easily.
Right. So it lets off its hydrogen easily, but that means that its carbon is largely sequestered in that core, the thing
How
that's
do
the
we
white
get
dwarf.
it?
So
Right.
it doesn't actually get back out into the universe, right?
Oh,
The
no.
hydrogen and helium does, but the carbon doesn't. And so
those stars are so greedy.
But then there are these other stars complicating the picture.
right,
the
there
bigger
are,
ones.
Right, the high mass stars do a weird thing, right? The high mass stars blow up much more violently at the end of their lives, and they go through.
There's a violent breakup.
Right, it's a violent
not
breakup, and
it's not letting them down easily.
right, and, yeah, very very violent thing, and they make all of the heavier things, right? They go through carbon and make oxygen and nitrogen and neon and all the various other things all the way up to iron, and then the thing blows up, and so all of that stuff gets thrown out into space, and as the thing is violently exploding, there's a lot of
Makes
energy
even
around,
more
and it makes
stuff.
even more stuff. So even heavier things, lead and gold and all kind of fun stuff.
Woo!
So that's where some of the carbon certainly comes from, is the big stars exploding. But it turns out we have some new results that indicate that the low mass stars are also playing a role in spilling that
Right.
carbon out into the universe.
Right.
Yay.
Yeah, this has to do with, so the low, go ahead.
I was going to say, which is reassuring, because as we were already discussing, there's a lot more
Yeah, they're way more
low mass stars.
Yeah, so it was a little bit of a mystery because even though the high mass stars do a really great job of spreading stuff out there are very few of them, right? So high mass stars are typically stars that are more than about 8 times the mass of the sun, and the number of those is minuscule compared to the number of stars that are solar mass or half a solar mass or something like that. So there's just not enough of them to really reseed the universe with enough carbon to have, carbon-rich environments for life to form and all that kind of stuff.
There's also this really interesting question in the sort of the life of a galaxy where those high mass stars, they also burn through their fuel much more quickly, so they don't last as long.
Right.
So you make a high mass star, and it in an astronomical blink of an eye burns all the stuff, makes all the stuff, blows up, and dumps all that stuff out there. And so there's a life cycle for the galaxy too, of like early on, your star formation rate is high. Oh, we had a trivia on this once, I think. What's the current star formation rate in the Milky Way?
I don't know. It was something
7.
like a few solar masses per year.
It's very close to like a star per year,
Yeah.
basically, which is kind of
Is that
amazing.
what the movie A Star is Born is about?
It is.
Oh, cool.
It is.
I cried at that movie,
Which one? Which version?
the new one.
Okay.
The one where it's 3 solar masses per year.
Yeah.
So anyway, that's just an interesting aside. But early in the galaxy's life, that rate of star formation was probably much higher. And in 10 billion years, it's probably going to be much lower.
Right.
And so there's this other interesting thing about sort of the rate that you're putting things like carbon and nitrogen and oxygen and silicon into the sort of the shopping bag of new stars to form planetary systems to make Vulcans and humans and Klingons changes over time. But a lot of it depends on how much of that stuff is coming from the big stars that are blowing off, having the violent breakups, and the low mass stars, which are blowing off gently.
Right. Right. And that ratio is kind of changing, right? Early in the galaxy's history, almost all the carbon, of course, was created by the high mass stars, because the low mass stars take a very long time to die, take billions and billions of years to die, and so the amount of carbon being, or the fraction of the carbon in the galaxy being produced by low mass stars is slowly increasing as more and more of those are starting to die. Stars like our sun are still not really too many of them dying yet. Our sun has a lifespan of about 10 billion years, and we're about halfway through ours. But some of the first solar mass stars to be born in our galaxy are now dying because our galaxy is 10 or 12 billion years old.
So the sun will get to carbon and higher or not? How far
No.
will the sun go?
The sun
in
will
terms of
go to carbon,
And that's
then
it.
That's it. But
Stuck.
what this paper is actually indicating is it's not even like a star just like the sun that is going to do this leaching of carbon back into the galaxy. It's a kind of specific range of masses. It's these stars that are like 1.8 or 1.9 times the mass of the sun. They do a funny thing kind of toward the end of their life. They still, all of these things kind of end at carbon, but when the sun blows off its outer layers, those outer layers still will be mostly made of hydrogen helium. But the 1.8, 1.9 times the mass of the
stars
sun
a little
stars,
bit bigger than the sun.
yeah, they turns out that they produce more of the carbon. They're higher mass stars. They produce more of the carbon, and some of that, or a fair amount of that carbon, actually does get blown off with the hydrogen helium at the end of the life. So.
Right. This new discovery was that they're making more carbon than we previously were aware that they were making.
Right. And so so it's
So that there's
kind of
more carbon to sort of get carried away in that gentle breakup.
right of stars in this specific niche of masses. Right.
Yeah.
So cool.
Yeah, and somewhat related to that, there's also a new paper about calcium
Also important for us.
for strong
Strong
teeth
and healthy bones and
I'm
teeth.
not drinking milk right now, but yeah. There's so calcium. So we get most of our, as we already said, right? We get a lot of the heavier elements from exploding stars. But understanding like exactly when things are made and where they're made and how is complicated. But it turns out that we think that there's this new study that came out that calcium probably comes from calcium-rich supernovae.
Is that different from a regular supernova?
Yeah, these drank a lot of milk before they exploded. They're a little bit different. So I think we've had trouble finding calcium in the past. Like it's just been harder to observe. But they, in a new study, they looked at.
There was sort of a serendipitous discovery of one of these supernova.
Yeah, from an amateur astronomer, I think. Right, they were like some of the supernovae were sort of anomalously bright in certain wavelengths.
So he was looking at this guy Joel Shepard in 2019 was looking at another galaxy. So this was not in our galaxy, and saw a bright orange spot and sent out an alert to the astronomical community.
Yeah, they're still called telegrams a lot of times, astronomical telegrams,
Yeah.
but they're usually just.
Now they're emails.
Basically tweets these days, but yeah,
Oh,
emails
tweets,
or notifications that go out to the
Oh,
community.
I can't believe I said emails. It's so 20-aughts of me.
I know, right?
Gosh. And so lots of big telescopes were pointed at this thing. So we've only captured we've bemoaned previously how we haven't had the good fortune to see very many supernova in our own galaxy in the modern astronomical era, but we see them regularly in other galaxies, and that's what this one was.
Yeah, and there's interesting observations across a number of wavelengths because they've been able to look at supernova more recently. We were able to look at supernova sort of like right after they happen with a bunch of different wavelengths, right? There's like good response times, and you can see it with a bunch of different telescopes. Ooh. And so this one in X-ray, there is more information that there is basically it's calcium that's created in the supernova itself. So it's actually reactions that are happening as the supernova is occurring that's like adding calcium to the material that's being thrown out. It's not just being created in the star, it's actually being created in the supernova reaction itself.
So that's giving us teeth and bones and chalk,
Hooray.
right?
And yeah.
Yeah. What else do you need calcium for?
Nobody
I don't know.
uses chalk very much anymore.
I know.
Calcium.
Although
that's
actually, there's I go running along like a big bike path, and there's some kids that live along it, and there's been lots of fun chalk drawings when all the kids are at home.
Tums is chalk, isn't it?
True. I think so. Yeah, calcium carbonate. Right?
Antacid, right?
Yeah.
The White Cliffs of Dover.
Yeah, there you go. I've never been there.
So, thank you, stars,
Yeah.
for providing us with all those handy elements. What's your take on how many of these
Okay.
Oh shoot.
That's
stars are in our local vicinity? How many star systems, how many stars within 5 parsecs? Parsec is astronomers' is one of our many funny units, which is a little over 3 light years.
Mm-hmm.
So it's about 16 light years from Earth.
How long is the Kessel Run?
Sorry?
How long is the Kessel Run?
Oh, I don't remember. Did the Kessel Run in... It's somewhere between 10 and 20. How long is the Kessel Run? That should have been the trivia.
It should have been. Yeah.
All right. Well,
It would have tied into.
I'm going to say in 12.
I think it was like
8.
It's supposed to be a certain length, and they do it in a shorter length.
Yeah.
Somehow 12, I think, right? Isn't it 12?
I don't know. I'm guessing.
I
I
think
thought
it's
you were
12.
looking it up.
I am looking it up, but I stopped to talk.
Okay. How many stars within 16 light years of Earth?
400.
Of course, there could be more. We've
These
seen.
are star systems.
Star systems that
400.
we've discovered.
Right.
So there could be more than this, but that we've discovered. Jim says 400 within 16 light years.
Correct.
42.
Addie wins. 52.
52.
Oh, okay.
Oh, very close. Good job.
That's not counting the sun.
I went with
52
an order
stellar
of magnitude
systems.
different, but also the answer.
How many stars?
75.
58.
63. Addie wins again.
Oh my, she's on fire today.
Yeah. How many brown dwarfs? How
very
many
warm.
white dwarfs?
That we've discovered?
Within this same
Within
thing,
the same
yes.
population?
Yep.
5 white dwarfs.
2 white dwarfs.
And a partridge in a pear tree. 4 white dwarfs. Addie's 3 for 3.
Jeez, she's
And-
killing it.
On fire.
And 10 brown dwarfs.
16 brown dwarfs.
11 brown dwarfs.
Oh, I should have gone with 11. That's my number.
Yeah.
11 or 22.
So now, okay, here's your last one. So there's 52 other star systems nearby, right? That's pretty close, aside from the sun. 63 total stars. How many of those are visible to the naked eye in perfect viewing conditions?
What magnitude is that?
That's like 6.
Okay. That doesn't help me, but just checking.
48 of them.
3.
9.
You still
Addie
win.
still
Oh my
wins.
god, just
Still
killing
wins.
it.
This is, yeah, and you were the one saying, "Oh, I
You're
never
so
win the
optimistic,
trivia
Jim.
because it's always about rockets and the moon."
Yeah.
And how come
Yeah.
it's never about,
now it's about
stars?
and I lost all of them. 5
You lost,
for 5.
You're
yeah.
0 for 5.
0 for 5.
Yeah,
Yeah.
that's pretty bad.
That's pretty bad.
So yeah,
You were too
it's-
optimistic, Jim.
It's
And all of your
I know.
answers.
Well, I think
Yours are probably closer
I
to
think
the
by
real
the
numbers.
actual answers, right?
Yeah. We
Given-
just haven't discovered them yet.
given that they're obviously faint, right? So
Also, maybe I discovered them and I'm just not telling you about them.
52 stellar systems. We can only in principle see 9 of those with the naked eye, and there's probably only a couple that in sort of realistic Earth observing conditions in the modern era could be observed
Right.
with the naked eye. The nearest one, of course, we've talked about multiple times, is this 3-star system,
Alpha Centauri.
Alpha Centauri, which is a little over 4 light years away, right?
Right.
But these we're all on our merry way around the Milky Way, all these stars and our neighbors. And so as we go, we're not all traveling at the same speed, so sometimes they come closer to each other than other times. So this isn't like a number that's fixed, or constant or anything like that. And so sometimes there are stars that are closer to the sun than currently. So in a million years or so,
Approximately.
one star, Gliese 710, may pass within 20,000 astronomical units
Whoa.
of the sun, which
That's
is
crazy
Wow.
close.
That's actually really
that's
close.
less than
That
a light
surprises
year.
me.
That's less than a light year.
I mean, that's within our Oort cloud.
That's within the Oort cloud.
Watch it. You're getting in my Oort cloud.
Yeah.
Oh, my.
Hey, get out of my
That's going to
Oort
cause
cloud.
all kind of mayhem with
cause
the comets,
trouble.
right?
That is gonna, yeah.
I have a hard time believing this.
When is that going to happen?
I saw it on the internet, Jim. So
because
What?
like that's very recent. I mean, that's very not recent. I mean, soon.
that's a short time.
When is it?
And
Right.
if that happened
A
with
million
any
years.
regularity, our Oort cloud we wouldn't have one. Because the Oort cloud comets were largely thrown out in the early solar system.
Right.
And
But they get perturbed by things.
right, I'm saying that if a star coming 20,000 light years away will seriously perturb, and if that happened
true.
with any regularity over the course of 4 billion years,
Just
I would
better
think
hope
that
it's
would
not
throw
regular.
just about everything out.
Ooh, does this play into the potential survivability of planets in other systems and blah blah blah?
I don't know about that, but I don't know. This seems bizarre to me. We'll
So
have to dig
do
into
more
Gliese
research before next
710
time.
is and it's not a pipsqueak star. It's smaller than the sun, but it's not a pipsqueak. It's 0.6 solar masses.
Okay.
It is
Respectable.
Respectable.
projected to pass near the sun in a time frame well within the parameters of current models
Oh, that's important
of
too.
the local flow of stars, which runs for 15 million years. And the predicted minimum distance will occur in 1.281 million years. And this is based largely on Gaia measurements, which is this astrometric space telescope from the European Space Agency that measures the positions and therefore also the velocities of stars to very, very high precision. Suggesting a slightly, Gaia DR2 suggests a slightly closer distance. Previous estimates of 0.0676 parsecs, 0.221 light years, parentheses, 14,000 astronomical units.
That is so crazy
That's
close.
so close.
That's if
if
that's
you
true,
can
that's
express it in
terrifying.
AU, that's
Such a
super close.
distance would make for similar brightness to the brightest planets.
Yeah.
It'd be about 1 arc minute per year. And yeah, that could be...
That's going to throw a lot of comets in at us. That's going to be a dangerous time.
That's perturbing.
There could be yet another mass extinction.
Oh,
Hey, but it
snap.
won't be our fault.
Time to get... It won't be our fault.
And
Unless
there might
we...
not be anything
But
around
here's
us.
your
We
warning.
better,
You're
we better
hearing...
close the show because I got to get home and take care. I got to
Here's,
get ready for
you
this.
got to start preparing things,
man.
right? Start preparing. So here's your official warning from the
Brendan, if you're
astroquarks.
listening, be scared.
Be scared. This is what I'm actually scared about.
1.28 million years from now, and it'll take then some thousands of years,
I don't know
maybe
if the
tens
iPhone
of
calendar
thousands of
goes that far.
years for the comet storm
Yeah.
to come in and then
Yeah.
for one to actually hit us. But yeah, time to brush off your copy of Deep Impact, available on Blu-ray,
Yes.
to check out the nasty consequences of a comet hitting the Earth.
Is it on any of the streaming services?
I don't know.
It is.
Probably. Pops up here and there. I just got a check for it yesterday, in fact.
Nice.
$7.
$7.
Nice.
All right. Dinner's on you
After
tonight.
taxes.
What?
Yes.
That
Well,
in the bank.
while it may have felt like the time since you last watched Deep Impact, it was just another episode of Walkabout the Galaxy. Our research shows that some people love Walkabout the Galaxy, and we're pretty sure that sum is greater than n divided by 500 million, where n is our current number of listeners, and 500 million is a conservative estimate of the number of English speakers on planet Earth. This amounts to statistical proof that you can make the world a happier place by sharing Walkabout with your friends and family with excellent taste, though you may have to share it with thousands of people to net us one additional listener. Be sure to like us on Facebook to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, where you can see most of our updates, some of our bloopers, and all of our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag #WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Production assistance is provided by Diego Rodriguez. Jillian Gloria is Director of Marketing. Thanks to our listeners in Germany and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the astroquarks, signing off until the next episode of Walkabout the Galaxy.
Carbon.